Okay, another handy function within Aberlink is the CAD comparison with deviation tags.
Along with the traditional probing and reporting routine, Aberlink is able to quickly compare the CAD model to the actual machine part, probing selected positions and getting a live deviation tag representing the distance from probe to actual CAD model distance. When full inspection routines are not required for high repeat orders, asking for 1 in 5 or 1 in 10 inspections of parts is sufficient. This is an easy way to confirm that the machine part conforms to specification. Initially, our first article would have been performed for all dimensions required, but this is a quick and easy routine, saving time and ensuring the part does conform to the customer's expectations. Basically, you have to align the part, which is the part here on the left-hand side. Okay, we'll just run. This is a snapshot of the part, of course. Really, you only need to probe the 3 main datums to align them, which I've got there in black, but I've just put some other geometry there just for clarity, so you know that the part in the right-hand screen looks like the part in the left-hand bottom screen. So basically, we hit the best fit function. We link the datums, so this would be the plane datum A, our line which will be datum B, and C, which is the center circle. We then link them and we run a routine called do points fit. And as you can see, the CAD is now aligned to the probed part datums by 14 microns. So very accurate. The Tomelleri arm is very accurate for this Mercury arm. So what we can do now is we can probe away using our surface measure function. And as you will see, the points coming live on the screen on the left when I probe critical features or specific items that you need to maintain is in correct specification to the dimensional part. So surface, as you can see here, we've got our window, unit 18. I will just go and now grab the Mercury arm and I'll start probing. I'll do firstly is I'll just check the datum A. I'll check datum B. And also check datum C. There we go, 8 microns. So now all I'll do is I'll just pick away on some known areas of the part that are critical, and we'll see what the output provides us at a later date. So I'm just selecting anywhere on the profile. Look at that, 1 micron. Okay, what I'll do is I'll probe this, the slot, which a feature does fit in there. We'll see how accurate that is. And the cone, we'll throw a couple of points on the cone. We need a couple to make sure that it's within tolerance. And also our plane. We can see that the plane has been wire cut, so it's going to be a little bit out because it's a secondary operation. I think down the bottom here that it's fine. 0.1. 0.15. Also the cylinder down the bottom here, that's just a clearance fit, so it's got like a plus or minus 0.2 tolerance on it. You can see that that's 0.12, it's still within tolerance. Probe another point, and perfect. I'll do the plane on the side of it. Very, very simple, very, very easy. So as you can see, I've done 30 points at this stage. Majority of it is in green, which is all the 2D planar, more critical features. And of course the cone, planes and the cylinder are all oversized condition for clearance. This part, I'll just do a couple in the PCD holes to see how close they are, because we want to make sure and ensure that they are in the correct position. As you can see, they are popping up very, very accurately. So you don't actually have to go and probe all the diameters. Ideal, perfect. So as simple as that, we've got 36 points. Now we can resize the screen. I can actually then, all the points will populate here in the screen. Very easy to see by eye what features are correct, and you can actually go in and measure individual points if need be. I can easily grab that point, the plane, and get a size, and that would be 1.986, which is half of our 4mm probe, 3.99 down here in the bottom screen. And so yeah, it's an easy way of indicating where in the part something may be amiss. So you've got all your points here, and what we'll do now is we'll actually do a report. So we need to have the CAD graphic details. With graphic details, we can have our part names, CAD comparison report, Lucing Engineering. We can have a serial number of 1, 2, 3, 4, 5, 6, 7, 8 and 9, -001. We can then rerun, apply that. We'll take the feature profile and point positions off, only have the graphic details, which will be our XY, which will be the screen over here, and our CAD comparison window. Just run that program. So as you can see here, we've got our title block with all the information for the customer. Aberlink in the bottom right is the software. Lucing Engineering is the customer. And if we quickly look at our CAD graphic detail window, we have a color mapping down the bottom, as well as all the CAD deviation tags placed around the part, pointing to the area of the feature that needs to be reported on. And we can output that to a Excel spreadsheet, or we can print that to a nice PDF.
Job done. Saves you time. Doesn't need to be fully dimensional reported. So it's a winner. Very easy to use. Aberlink is the most simplest software I've ever used. Thank you.